The universe is expanding. In this three-dimensional space, everything is moving away from each other, flying apart at incredible speeds. The most distant galaxies are receding from us at half the speed of light, and new galaxies are being born every second. How fast is it all happening? This question has an answer, but be careful when you hear it, because the numbers are mind-blowing. The first piece of good news is that it's not necessary to know advanced mathematics to understand this issue. We only need primary school-level arithmetic. However, you should be aware that these numbers are so vast they can only be expressed in scientific notation. So before we start, let's remember what that means. Let's take an example, 2 to the power of 3. It means 2 times 2 times 2, which equals 8. In this case, 2 is the base, and 3 is the exponent. And this is exactly how we'll represent the numbers in this video. The base will indicate the number itself, and the exponent will indicate the number of zeros that follow it. For example, 10 to the 27th power would be 10 billion, 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 billion. Now let's get started with our first part, where we'll look at the size of the observable universe. But first, we must clarify that astronomers don't measure the size of the universe in miles or kilometers. Instead, they use a unit called a light year. 1 light year is the distance light travels in 1 year. Light travels very fast, approximately 300,000 kilometers per second, so it's no surprise that 1 light year is an enormous distance. In fact, 1 light year is 9.46 trillion kilometers. If we wanted to drive that distance in a car at 100 kilometers per hour, it would take us more than 31 million years. So now let's go back to our original question. How big is the observable universe? The answer is approximately 94 billion light years across. But wait, it gets even more impressive. The observable universe is not just a sphere, it's expanding. As we mentioned earlier, everything is moving away from each other. So the entire universe is growing like bread dough in an oven. How fast is it growing? Unfortunately, this is a difficult question to answer because the expansion of the universe is not constant. In some places, it's faster. In others, it's slower. Luckily, scientists have discovered a way to measure the rate of expansion. They do this by studying distant galaxies. These galaxies are so far away that their light has been traveling for billions of years to reach us. As the universe expands during that journey, the light waves stretch, shifting the galaxy's position to the red end of the visible spectrum. By measuring how much the light has shifted, scientists can calculate how much the universe has expanded since the light was emitted. According to NASA, the average rate of expansion is 73 kilometers per second per megaparsec. Megaparsec is a unit of length used to measure distances between galaxies. 1 megaparsec is equal to 3.26 million light years. Therefore, the rate of expansion of the universe is also equivalent to 2.45 trillion kilometers per second per megaparsec. But how fast is that? Let's put it into perspective. The International Space Station orbits around the Earth at a speed of about 17,000 kilometers per hour. That's pretty fast. But compared to the expansion of the universe, it's incredibly slow. At the speed of the ISS, it would take almost 300,000 years to travel 1 light year. Meanwhile, the expansion of the universe is adding new light years every second. However, there's another piece of good news. The rate of expansion is slowing down. You see, the universe isn't just expanding, it's also getting heavier. More matter means more gravity, and gravity tends to slow things down. So as the universe grows older and heavier, the rate of expansion will continue to decrease. According to current estimates, the rate of expansion could drop to 0 in 10 to the 100 billion years. At that point, the expansion would stop, and the universe would reach a state of maximum entropy. Everything would be evenly distributed throughout space, and no new stars would be born. Now let's move on to the next part of the video, where we'll learn about the age of the universe. To understand how old the universe is, we must look at the stars. Stars are born in giant clouds of gas and dust, and the process takes millions of years. Once a star is born, it begins fusing hydrogen into helium in its core. This fusion generates energy, and the star shines brightly. However, this process doesn't last forever. Eventually, the star runs out of hydrogen and begins to die. Some stars explode as supernova, while others, like our Sun, simply fade away into white dwarfs. So to determine the age of the universe, astronomers study the oldest stars they can find. and based on their observations, they estimate that the universe is about 13.8 billion years old. Now let's multiply that number by the speed of expansion of the universe. 2.45 trillion kilometers per second per megaparsec, we get 33.6 trillion kilometers. That's how far away the most distant galaxies are from us. It's mind-boggling to imagine any kind of object existing that far away, yet it does. And the light from those objects has been traveling for billions of years to reach us. In just over 13 billion years, our universe has grown incredibly large, 33.6 trillion kilometers across. But the true size of the universe may be much larger. Remember that we can only observe the part of the universe that light has had time to reach us. There could be much more universe beyond what we can see. Scientists call this part the dark universe. We know that the dark universe exists because we can observe its gravitational effects on the part we can see. But we do not know how much bigger it is, or if it's the same or different from the part we can observe. Let's try to wrap up this video with one last amazing fact. You see, the universe isn't just expanding, it's also accelerating. That means the rate of expansion is increasing over time. In other words, everything is moving away from each other faster and faster. To understand how fast that's happening, consider the following. If the universe were a flat sheet of paper on which dots were drawn to represent galaxies, the expansion of the universe would be like blowing up a balloon on which those dots are drawn. As the balloon expands, the dots would move away from each other. Acceleration would be like inflating the balloon at an increasing rate, causing the dots to move away from each other faster and faster. And how fast is that? The acceleration of the universe is approximately 10 to the 12th power per second squared. To put that into perspective, if you were to drop a feather and a bowling ball in a vacuum, it would both accelerate at 9.8 meters per second squared. That's because the Earth's gravity is pulling them down. But the expansion of the universe is accelerating the galaxies at a much higher rate. In fact, it's 10 to the 23rd power times greater than the acceleration due to Earth's gravity. It's really hard to imagine anything accelerating that fast. So the next time you look up at the night sky, remember that the universe is expanding at an incredible rate. Galaxies are flying away from each other faster than the speed of thought. And the numbers behind this phenomenon are simply mind-blowing. The size of the observable universe is 94 billion light-years across. The most distant galaxies are receding from us at half the speed of light, and the rate of expansion of the universe is 73 kilometers per second per megaparsec. On top of that, the universe is also accelerating. All these factors combined make our universe a truly amazing place. If you enjoyed this video, please subscribe to stay updated on our latest content. Till next time, keep looking up.